So welcome to this class. In this session, we are going to do the analysis of a horizontal ellipse whose center is shifted away from the origin to a point HK. So that now we know how to determine the equation of that ellipse, and then the length of the major axis, length of the minor axis, length of the lattice rectum, and such things related to an ellipse. So analysis. Of an ellipse centered at HK, then major axis, parallel to the x-axis. So this is just still a horizontal ellipse. Solution. So let's draw the sketch for that. So let this be the center that we are referring to as H, K. So center H, K. Let's draw the ellipse. So let this be the ellipse. So this is the foci, and then let these be the vertices. And so let's label this one as F1, F2, F2, F1, V1, V2, V1, V2. Let's now have join this line passing through F2, this lattice rectum. This another lattice rectum. So call this one N1, call this end N2, call this one M2, call this one M1. So to be able to identify the coordinates of what we already know, that the distance from the center to the vertex is A units, distance from the center to the focus is C units, and then the coordinates of the center is HK. So those are the only things that we know. So if this is where we have the center, then it tells us that this must be the H, and then this must be K. And so we draw dotted lines. So through this point, and then draw another dotted line. And then we have this line. Then we have another line here. from this B. So what is going to help us now to read this, but so then you can extend this one to the X, and then extend this one to the X, extend this one to the X, and then extend this point to the X. Remember, this is the origin. So this is Y, this is X. Now from our previous calculation that the distance from this focus to the end of this lattice term is B squared over A. So this also B squared over A. This is B squared over A. And then this B squared over A. So because distance from C to F1 is C units, then we are moving, so this, remember, from C to F1 is the same as from this point to this point. So this one is C, so this will be H plus C. And from C to V1 is the same as from this point to this point. So this will be H plus A units. And then from here to here is C units, but to the left. So this will be my H minus C. And from here to here is A units, but to the left. So we have H minus C. And then when we go to the y-axis, so we don't know K here. So distance from center to the B2 or B1 is B units. So this from here to here will be K minus B, and this will be K plus B. This one is B squared over A, so this will be K plus B squared over A, and here we'll have K minus B squared over A. So with those labeling, then we are able to give the coordinates of each of these dotted points. So V1, X value is H plus A, and then Y value is K. So those are the coordinates of V1. And then V2 has coordinates H minus C, comma, K. So that's what we have. And then next, foci F1, X value is H plus C. And then, so remember, this is V2, this is A not C. So this must be A, because distance from the center to the vertex is A. So this is H minus A not minus C. So this is A. Now, for, yes, type properly. H minus A, this is minus A. H F1, H plus C, K. And then F2 has coordinates H minus C, and then Y value is still K. And then coordinates of B1, the co-vertices, B1, we have H, comma, this value is K plus B. And then B2, this one here will be K H. Remember this B2, so H and then K minus B. Ends of the lattice rectangle, so N1 will have coordinates X value is H plus C, comma, Y value will be given by K, plus b squared over a. And then n2 will be given by h plus c, comma, then k minus b squared over a. And then m1 will have coordinates h minus c, comma, and then this one is k plus b squared over a. And then m2 will have coordinates. So this one is h minus c, comma, this one will be k minus b squared over a. And then length of lattice rectangle remains to be b squared, 2b squared over a, just as we saw in what we discussed previously. Lattice rectangle will be 2b squared over a, and length of major axis remains to be the distance from B1 to B2, which is 2a units, and length of minor axis remains to be distance from the endpoints of the co-vertices, B1, B2, which is 2b. And finally, not really finally, eccentricity is given by c over a. And then the equation of all these horizontal ellipse is x minus h. So there's h units shift from the origin squared over a squared plus y minus k squared over b squared equals to 1. So this is the equation. And then remember that a is greater than c, and a squared minus b squared minus b, a squared minus c squared, a squared minus c squared is what gives you b squared. So this is how we analyze a horizontal ellipse whose center has been shifted from 0, 0 to a general point h, comma, k. So the next session will be analyzing the vertical ellipse whose center has also been shifted from the origin to a general point h, comma, k. And that one, its major axis is parallel to the y-axis. So thank you.